Go.
Hello, my dear students, and welcome to our flame test lab. I'm sorry it's taken me a while to get this recorded and posted. A lot of things have come up, but let's quickly run through the lab procedure, and then there'll be an accompanying video dealing with the debriefing and the lab discussion so that you can complete your lab report and get your grade. Don't forget, the lab reports play a significant part of learning chemistry, and more importantly perhaps to you, a significant part of your grade. They count 25%, just like our quizzes and tests. I'm going to turn the lights on. We'll get through this posted flame test procedure. There's two parts to our lab today. We're going to do flame test. We're going to excite atoms, raise those electrons to a higher energy level by putting a solution of some of these chemicals into a flame, and they will glow or burn or give off a specific color. And then we will look at some spectrum tubes where we excite hydrogen and helium and mercury. And when we do that, we'll get the same color you get in a flame test, but we'll look at it through a spectroscope so we can separate out the specific different colors that correspond to specific electron activities. And by that I mean electrons moving to specific energy levels and falling back down to specific energy levels as they shed that excess energy as heat and light according to the quantum model of the atom. I'm going to turn the lights on so we can go back to the lab. We'll be using Bunsen burners. The next lab, we're going to do more flame tests, and we're going to boil water so that we can follow some chemical reactions. And I'll have a separate video on how to safely light and use a burner and how to safely boil water. So today, I'll just quickly run through our lab. Actually, I'm going to turn this on, and I'm going to go turn those lights off again because the colors are more vivid when it's a little darker. So I'm turning my gas on and lighting my Bunsen burner. I'll be right back. We haven't learned to pause or video edit yet. And now, in the order the different elements are listed in your lab report, we're going to first look at a tube of barium chloride. I have a nichrome wire loop. The procedure calls for us to heat the loop to glowing, and then I will cool it off, and the tiny loop has a bit, and you have to watch quickly on this one. It will quickly give me a pale yellow or yellow-green flame and then go back to orange. That was it. Some of them, as you'll see, will persist longer, but here's your flame. 3, 2, 1. Yellow, and then back to orange. That was our flame test for barium chloride. Our next one is calcium chloride. This one's a little difficult to interpret because in this case, calcium chloride gives us an orange color. When I heat up this loop, it's nickel chromium steel, so it's nichrome wire, nickel chromium, basically stainless steel wire. It glows orange, and pretty much so does calcium. So watch the color of orange change slightly. You had a brilliant kind of reddish orange for a second. I'll do it one more time. There it goes. And that flame persisted for a while and then back to the regular orange. And I'll continue to use this flame so that I can stop and do it. This is a solution of copper chloride. And this loop, if I get it to go orange here and get all the remaining copper off from the last student in the last lab who used it, I'm going to do copper now. This is copper chloride, and watch, you will see a very dramatic color produced. This gives a blue-green, and if you follow the flame, you'll see some hints of yellow. That's a different electronic interaction as you heat it up to a higher energy level and it falls back down further and emits some yellow light. Beautiful green and blue, and if you look inside the flame, you'll find some yellow highlights. Very distinctive. One of the values of this is that if I have an unknown solution, I can take that unknown solution, do a flame test, and identify what's present. This is potassium chloride. In Texas, we do our barbecue. Come on in closer. And I'm going to go back over to the other one because it's a little darker. This is a real faint color that we're going to observe here. But in Texas, our barbecue is beef, not pork. But the other thing is we don't do hickory smoked. We do mesquite smoked barbecue. And mesquite wood, if you've ever had a mesquite wood fire, glows kind of purple because it concentrates a lot of potassium in the plant tissues as it grows. Mesquite trees do. So watch carefully and you'll see a lilac flame. This one again is a quick one though. This one isn't one that is a persistent color. This one is very short-lived. I'll try to catch it a little better. The purple was in there. Lilac for a second. And then quickly back to orange. There was your purple, and now back to orange. Lilac, very pale purple there, and then back to orange. The next one is lithium. A lot of fireworks, when you wanted to have a red fireworks, you included lithium salts. Not so much anymore because lithium's gotten expensive since we're using so much of it in lithium hydride batteries for our cell phones, our cars, and our computers. But this is lithium chloride. I'm going to put it in the flame. You're going to see a beautiful red scarlet color that is itself rather persistent and stays around for a while. There you go. And then it will go back to orange. So lithium gives a really strong, incredible, beautiful red color. There we go. And a very distinctive color. Instead of lithium, you can use strontium. That gives a nice, good, strong red color. And in our next lab, we'll be doing flame tests with strontium. Our final one today for the flame test is sodium chloride. Sodium again is not so dramatic because like the wire itself, it gives an orange flame test. So you're going to see orange, orangish yellow, and then back to orange. You're going to see one color of orange and then quickly there, and then back to the other color of orange. But we will record these and write these down in the data and discussion aspects of our lab. And finally, the lab calls for spectral analysis using spectrum tubes for 3 different elements: mercury, hydrogen, and helium. And they show you the spectrum of helium, so I didn't set up a helium one. I have a helium tube, but I have to swap things out, and it is just an additional step. For this, we need a spectroscope. I have several here. This one is more for astronomers for looking at stars and analyzing them. We use these inexpensive spectroscopes that do a really good job of separating out the line spectrum. Unfortunately, I experimented with putting the camera up to this and didn't have very good luck. But if you align this slit window with the spectrum tube, the skinny part of the spectrum tube, and look off to the side, you will see a very distinct line spectrum where you separate out the colors and you get to see all of the spectrum. And you can use either one of these. I rather like these. These have a really clear number system on them. If I can get the window, there's the window. Over on that side. Oh, beautiful. I wish I could show you. But what this is mercury vapors inside a tube. They're being excited by a very high energy current. You can hear the transformer buzzing. And they, this color, this pale bluish white color, is a combination of several of the different lines that come together to form the one color. But the spectrogram lets you separate those out. And this one here is hydrogen. One of the simplest ones, and the original one that Niels Bohr used, using equipment very similar to this, to deduce the line spectrum for hydrogen. Because remember, hydrogen is element number 1, 1 proton, 1 electron. But that 1 electron can move into lots of different orbits when it's excited, and it can fall back down to a variety of different orbits and produces some very unique spectral lines. I will post a picture of the spectrum so that you can see what you would have seen had you been in lab and saw the spectrum. So, that's our lab. I will post the actual lab debriefing and discussion in the next video. Until then, stay safe.